When astronomers first spotted 3I/Atlas, it was just a faint smudge, another comet from the outer solar system. It seemed routine icy wanderers like this pass by often, tracing long elliptical paths around the sun. Early calculations showed 3I/Atlas would pass harmlessly through the inner solar system, a cosmic tourist on a predictable route. The scientific community logged its discovery, gave it a name and moved on. But this comet was different. It was interstellar, a rare visitor from beyond our solar system. That made it a scientific treasure, but its trajectory still looked safe. For a while 3I/Atlas was just a fascinating object to study, expected to brighten near the sun and then vanish back into the void. Yet the universe rarely sticks to the script. Comets are unpredictable, fragile mixtures of ice, dust, and gas. As they near the sun, their ices sublimate, creating beautiful tails and erratic behavior. The initial projections assumed 3I/Atlas would behave like a simple inert object. That assumption was about to be shattered. What began as a quiet astronomical footnote soon became the focus of urgent meetings and frantic calculations. The comet was hiding a volatile secret, one that would soon force us to look at Mars with growing concern. Sometimes the faintest smudge in the sky can change everything. The first sign of trouble came quietly, from supercomputers at the Harvard-Smithsonian Center for Astrophysics. Updated simulations showed 3I/Atlas was drifting off its predicted path. The deviation was subtle but persistent. NASA's Jet Propulsion Laboratory confirmed the findings. The comet's trajectory was changing. Suddenly, Mars was in the potential crosshairs. The astronomical community mobilized, turning every available instrument toward the comet. The question was urgent. What was pushing 3I/Atlas off course? Unlike planets, comets are subject to chaotic forces, jets of gas, unpredictable eruptions. The public announcement was measured but serious. There was now a non-zero chance of a close approach or even an impact with Mars. The story captured imaginations worldwide, a cosmic drama unfolding in real time. Space agencies shifted focus from curiosity to crisis management. The fate of our robotic explorers on and around Mars was suddenly at stake. The world watched as scientists raced to understand the comet's next move. The question was no longer where did it come from, but where is it going? The answer would determine the future of Mars exploration. The clock was ticking. The mystery deepened as scientists studied 3I/Atlas's behavior. Instead of steady outgassing, the comet erupted in unpredictable, powerful jets, like a cosmic heartbeat. Each pulse nudged the comet, altering its speed and direction. These eruptions, driven by volatile ices beneath the surface, made its path nearly impossible to predict. Tracking 3I/Atlas became a game of probabilities, not certainties. Observatories analyzed the light from the comet, revealing the chemical makeup of its jets. Every pulse was a new variable, complicating computer models, some missing Mars, others passing dangerously close, or even hitting. The comet was a wild card, rewriting its own fate with every rotation. Scientists raced to update their models, but the randomness of the jets kept everyone guessing. The drama was no longer just about gravity, but about chaos. 3I/Atlas was steering itself, and Mars was directly in its unpredictable path. The stakes had never been higher for planetary science. The comet's erratic heartbeat was now the engine of a cosmic crisis. NASA's simulation teams worked around the clock, mapping the risk zone around Mars. Thousands of computer models, each with different assumptions about the comet's next eruption, painted a sobering picture. The probability cloud showed Mars squarely in the danger zone. A narrow keyhole in space meant that if 3I/Atlas passed through, impact was almost certain. Even a near miss could be catastrophic. Mars's orbiters and rovers faced a deadly barrage of high-speed dust and debris. The comet's coma, a vast cloud of gas and particles, threatened to sandblast anything in its path. As the projected encounter date in 2026 approached, every new observation refined the models, but uncertainty remained. The fate of decades of Martian exploration hung in the balance. NASA's teams updated their forecasts daily, racing against time. The simulations were humanity's only window into a potentially devastating future. The world waited, hoping for a cosmic near-miss, but the risk was real and growing. If 3I/Atlas struck Mars, the consequences would be catastrophic. The impact would unleash energy equivalent to millions of megatons of TNT, carving a massive new crater. A colossal plume of rock, dust, and water vapor would rise, creating a temporary sun in the Martian sky. The aftermath, a global dust storm, blocking sunlight for months or years, plunging Mars into a deep freeze. Subsurface ice would vaporize, injecting water into the atmosphere and possibly triggering unpredictable climate changes. Our robotic explorers, rovers and orbiters, would face destruction. Rovers could be buried or disabled by dust, orbiters shredded by high-velocity debris. Decades of exploration and billions in investment could be wiped out in hours. Even a near miss, with Mars passing through the comet's coma, would threaten to disable or destroy our machines. Solar panels would be coated in dust, instruments damaged, missions cut short. The arrival of 3I/Atlas threatened to silence our outposts on the Red Planet. The future of Martian science hung by a thread. The stakes had never been higher. The 3I/Atlas crisis was a wake-up call for planetary defense. Until now, our focus was Earth, protecting our home from cosmic threats. But with assets and ambitions on Mars, our responsibilities have grown. Planetary defense must now extend to every world we explore. The tools we develop to protect Earth, like asteroid deflection, may one day save Mars. The need for such technology is no longer theoretical, it's urgent. We must expand our sky surveys, watching for threats to all our outposts. The potential impact on Mars is also a scientific opportunity, offering insights into planetary evolution and the origins of water and life. The 3I/Atlas event reminds us that the solar system is dynamic and sometimes violent. As we venture further, we must think like a multi-planetary species. Protecting our investments and scientific potential on Mars is just the beginning. The story of 3I/Atlas is about more than a comet, it's about our evolving role as explorers and guardians. The future of planetary defense starts now. The saga of 3I/Atlas is a profound lesson in cosmic humility. It highlights the fragility of our technological civilization as we reach beyond Earth. Space is not just a frontier, it's a realm of unpredictable dangers. The journey of a single comet can threaten decades of achievement on another world. Our instinct to protect Earth must now expand to our robotic explorers across the solar system. These machines are our eyes and hands on distant worlds. Their loss feels personal. We are beginning to see the solar system as our backyard, not just a distant wilderness. Planetary protection must be holistic, defending Earth, our robots, and even other worlds from contamination. The 3I/Atlas scenario shows we must be ready to act as guardians, not just observers. Whether the comet hits or misses, its story is a dress rehearsal for future threats. Our vulnerability travels with us, but so does our ingenuity. The tale of 3I/Atlas marks our transformation from passive observers to active participants in the cosmic drama. The universe is vast, but we are learning to protect our place within it.